Hello, welcome to Astronautics for Exploit. This is Dr. Anyashola Ogundele. Applications of interplanetary internet, a cosmos system of interconnected networks and nodes. The focus points are as follows. Evolutionary architecture of interplanetary internet and applications of interplanetary internet. The internet, a global system of interconnected computer networks and electronic devices that communicate with each other and share information via an established and standardized Internet protocol suite, is dated back to the 1960s. The first conception of the idea of Internet is credited to Licklider of MIT, who in August 1962 described a galactic network where anyone could access data and programs from any location in the universe. Several pioneering scientists, programmers, and engineers contributed immensely to the development of Internet Protocol Suite, rules for communication between networks and devices on the Internet, and evolution of the Internet. The launch of the first artificial satellite, Sputnik 1, spurred the formation of the ARPANET, Advanced Research Projects Agency Network, the network that metamorphosed into the same Internet. On October 29, 1969, the ARPANET, which enabled multiple computers to communicate with one another on a single network, sent its first message from a computer located at the University of California to another computer located at Stanford. Since then, Internet has been evolving into a better form day by day. Various applications of interplanetary Internet are mission status telemetry, command and control, interconnectivity of intelligence, artificial intelligence, enhanced robots, Apple Interplanetary, teleoperation of extra robotic rover, scientific data delivery, and interplanetary overlay network. Evolutionary architecture of interplanetary internet. Government space agencies and private space companies have developed the technologies to conduct many missions for the purpose of exploring the universe, find alternative resources, and broaden its science. Currently, the communication architectures supporting the space missions are point-to-point and mission-dependent. Solo Wi-Fi access points is shown in this picture. Presently, there are various proposals of an evolutionary architecture of interplanetary internet, also known as solar system internet, to migrate from mission-centric architectures to a single common scalable and reliable architecture. Several solar system internet potential applications have been put forward. Interplanetary internet coverage concept is shown in this picture. Applications of interplanetary internet. Some of the applications of interplanetary internet are as follows. Mission status telemetry, command and control, interconnectivity of intelligence AI-enhanced robots, Apple Interplanetary, teleoperation of extra robotic rover, scientific data delivery, and interplanetary overlay network. Mission status telemetry. The status and the Earth report of the mission, spacecraft, or the landed vehicles could be delivered to the mission center or other nodes. This application requires periodic or event-driven transmission services. Extension of the current space communication capabilities into interplanetary internet will help in achieving real-time mission status telemetry. This area is an important application path. Illustration of exoplanet in the solar system, which will benefit from the interplanetary internet service is shown in this picture. NASA chose Lightstreamer as the push streaming engine for delivering real-time telemetry data from the International Space Station to web and mobile applications. International Space Station Live is a web application that uses a proprietary chemistry technology, which is referred to as Lightstreamer, in order to push data across the internet using the standard HTTP port. ISS Live uses the push technology in order to display real-time telemetry and mission timeline data from the space station in any common web browser or Internet-enabled mobile devices. Atmon Communications System is shown in this picture. Command and control is another application of interplanetary internet. An important application of the interplanetary internet is the command and control of in-situ elements. The closed-loop command and control may involve indirect or multi-op communication of the remote nodes. That is, Earth station controls the mission rover on planet surface, or close proximity nodes, that is, planetary orbit, controls the lander. The Deep Space Mission System provides tracking, telemetry, and command services for a broad spectrum of deep space missions. Illustration of the future of space exploration using interplanetary internet is shown in this picture. In-situ resource utilization is the harnessing of local natural resources at mission destinations instead of taking all needed supplies from the Earth in order to enhance the capabilities of human exploration. NASA conducted ISRO analog missions in collaboration with the Pacific International Space Center for Exploration Systems and the Canadian Space Agencies. They validated ISRO hardware that characterizes and extracts compounds like water and carbon dioxide from the volcanic remains. The same technology could be used to look for water ice in lunar or other planetary environments with the aid of interplanetary internet. Illustration of human journey to the Mars is shown in this picture. Interconnectivity of intelligence AI-enhanced robots is another application of interplanetary internet. AI is crucial for in-orbit of things because it enhances IoT's capabilities by enabling data analysis, predictive insights, automation, and intelligent decision-making. AI processes the vast amount of data generated by IoT devices, making IoT systems smarter, more efficient, and capable of proactive actions. Artificial intelligence significantly enhances a robot's capabilities by enabling it to process data more sophisticatedly, learn from experience, and improve performance over time. Illustration of interplanetary internet strategy is shown in this picture. AI-powered robots support sustainable space exploration. They are also contributing to advancing the Sustainable Development Goals, revolutionizing approach to exploring the cosmos. The augmentation of autonomous functionalities in space robots promises enhanced sustainability, cost efficiency, and resource management. AI's adaptability over time enables the correlation of observations, responsive adjustments to changing conditions, and refinement of control mechanisms, thereby laying the groundwork for more sustainable and efficient space exploration endeavor. Extension of Earth's Internet to Mars with orbital data services is shown in this picture. Interconnected intelligence AI-enhanced robots via interplanetary internet is contributing immensely to different stages of a space mission. It ranges from computing machine learning all the way to involving AI in the embodiment of the Earth design. The quest for long-term sustainability beyond Earth is necessitating innovative solutions of interplanetary internet. SMR's Express relaying data from Zoran rover is shown in this picture. Apple Interplanetary is another application of interplanetary internet. To lead the immersive space race, Apple is gradually integrating spatial computing features into the iOS ecosystem. Apple is working on integrating its software, iOS, Siri, maps, and apps into terrestrial and extraterrestrial vehicles. This will one day lead to capability in interplanetary internet that will help to connect nodes in interplanetary space and on celestial objects. Signaling across the cosmos is shown in this picture. Teleoperation of SA robotic rover is another important application of interplanetary internet. Future missions will call for astronaut teleoperation of robotic systems on planetary surfaces from orbiting spacecraft, as well as human teleoperation of surface robotic systems on the Moon from the Earth. The impact of DTN on telerobotic missions is of strong interest. Particularly interesting is determining what it will take to achieve end-to-end communications and what limitations or advantages can be expected. Delay disruption tolerant networking, which enables the use of multiple parts and providers to efficiently deliver data, is shown in this picture. Telerobotics is a key technology for operating robots on planetary surfaces with minimal latency. Teleoperation can speed deployment of autonomous vehicles by decades. NASA and ESA successfully used an experimental version of Interplanetary Internet to control an educational rover from the International Space Station. The experiment used NASA's disruption tolerant networking protocol to transmit messages and demonstrate technology that one day may enable Internet-like communications with space vehicles and support habitable infrastructure on another planet. High-rate delay tolerant networking is shown in this picture. Scientific data delivery is another application of interplanetary internet. Scientific data delivery are in two forms: time-sensitive scientific data delivery and time-insensitive scientific data delivery. The main objective of interplanetary internet is to realize communication between in-space entities, allowing large volume of scientific data to be collected from planets and moons. Illustration of interplanetary internet is shown in this picture. Time-sensitive scientific data delivery is another application area. This type of application is required to deliver great volumes of audio and visual information about the local environment to Earth, in situ controlling robots, or eventually in situ astronauts. A blueprint for a commercial interplanetary internet is shown in this picture. Interplanetary Evolving Network is another application area of interplanetary internet. It's an implementation of delay disruption tolerant networking. DTN is a digital communication networking technology that enables data to be conveyed reliably among communicating entities when round-trip times may be highly variable and or very long. Illustration of internet spreading across the solar system is shown in this picture. In DTN, data transmission is done automatically and reliably, even if one or more of the network links in the end-to-end path between those entities is subject to very long signal propagation latency and or prolonged interface of unavailability. Our DTN is suitable to both planetary and interplanetary environments, susceptible to communication delay and disruption. So-style Wi-Fi access point is shown in this picture. For more information, contact Astronautics for Export. You've been watching and listening to Applications of Interplanetary Internet, a cosmos system of interconnected networks and nodes, presented by Dr. Ayanshola Ogundele, with focus points evolutionary architecture of interplanetary internet and applications of interplanetary internet. Thank you.